Hey everyone, it's Justin again. Previously, you learned how to reverse engineer functions from their graphs. In this video, you're going to learn how to do the same thing using tables of data. At the end of this lesson, you will be able to write exponential functions based on the information given in data tables. First, you will learn the differences between data tables and graph points when it comes to writing exponential functions. Then you'll watch and take notes as I work through 3 examples while teaching you how to work around some of the obstacles you may run into in the process. First, let's take a look at the difference between graphs and tables. Both of these represent the same function. Graphs are usually centered so that you can see the initial value. Tables also often show the initial value, but sometimes the data is so scarce that you don't know many of the data points, including the initial value. Later, we'll cover how to figure out the initial value in cases like this. Tables do have their own benefit, though. We can actually see the exact values of each output. On the graph, it's a lot harder to tell the values unless they happen to be directly on the grid lines. So unlike graphs, tables just give us the values. It already sounds like writing functions from tables will be even easier than from graphs. So let's try an easy example first. Let's take a look at this table. We've got multiple data points, all exactly 1 unit apart, including when the input is 0. Since we know the output for 0, that's our initial value. Now we can move forward 1 unit to input 1, and just like with graphs, divide to find what the multiplier is. 10 divided by 5 is 2, so 2 is the growth factor here. If we look at the rest of the data, this makes sense as each output is double the previous one. Since this calculation was made using an interval of only 1 unit, the exponent stays just as x. So our function for this data is 5 times 2 to the xth power. In other words, it starts at 5, and then it doubles every 1 unit. That was easy. But it's not always so easy. There are a few things that can make it harder, like more spaced out inputs. In this table, we only have data in input intervals of 3. But that's okay. We already know how to handle wider intervals. We can see that the initial value is 39,366. And 3 units later, it has decayed down to 11,664. We can divide these to find the growth factor. We just have to adjust for the 3-unit interval by making the exponent x over 3. From here, we can either leave it like this, or we can turn the fractional exponent into a root in order to find the 1-unit interval growth factor. These are the same function, just written over different intervals. If we needed a function over 2-unit intervals, we would just square the growth factor and account for the interval in the exponent. Remember, no matter what interval you've been given, you can always convert it into any other interval. The final tricky situation we may run into is when data for the initial value is unknown. Does this mean we can't write the function? Of course not. We just have to extrapolate the initial value by using the data we do have. So let's find the growth rate first. Since we have 2 data points, we can divide them to get a growth rate. Remember, this is the growth factor over 2 units, so we can take the square root to find the 1-unit interval growth factor, which ends up being 1.1. Now that we've got the 1-unit interval growth factor, we can start at the data point for input 1 and move backwards 1 unit to find the initial value. In order to move backward, or to the left if we were looking at a graph, we would have to divide by the growth factor instead of multiplying. So we get an initial value of 5,000, which allows us to complete the function. 5,000 times 1.1 to the xth power. If you use these tips and tricks, you'll be able to write a function for any data set, no matter how big or how small. Just remember to make sure it's exponential. Don't waste your time writing an exponential function for a linear data set. In the next video, we'll learn how to use a calculator function called regression to write functions for more realistic data sets. See you then.